Hi, we're going to continue on with some more stoichiometry. In our last video, we learned how to use the coefficients in the balanced equation to convert from moles of one thing in the balanced equation to moles of something else in the balanced equation. Well, now what we're going to do is we're going to use the things that we learned prior to that mole-to-mole ratio and put it all together. So basically what we're doing is we learned this step. We learned how to go from moles of one thing to moles of something else in our last video using the coefficients from the balanced equation. Well, now we're not going to necessarily start with moles. We may start with a mass and we convert to moles, and then we're going to want to know moles of something else. So we'll come over here, or maybe we're going to want to go to grams of something else, or maybe particles, or maybe the volume of a gas at STP. So don't forget what we've already learned. And then we've just added this one other step in here, that mole-to-mole ratio. Okay, so let's go ahead and practice. So I looked for a balanced equation that had some pretty odd coefficients. So here we've got copper metal, and if you put it in nitric acid, you will get copper 2 nitrate, nitrogen monoxide, and some water. So let's go ahead and start with 3.5 grams of copper. And the question is asking us for how many grams of nitric acid do we need to react with that copper? And so we want to know how many grams of this nitric acid needs to react with the copper. Well, the first thing you have to do is convert what you have into moles. So let's go ahead and convert that 3.5 grams into moles. And 1 mole of copper has a mass of 63.55 grams. And so when we take our grams of copper, divide by its molar mass, we come up with, to 2 significant digits, 0.055 moles of copper. Now, we're ready to do our mole-to-mole ratio because we have moles of copper, and now we have to convert to moles of nitric acid. We can't go directly from moles of copper to the grams of nitric acid. We have to change from one thing to another using their mole-to-mole ratio. So again, it's very important that you use your units. So you've got moles of copper, and we don't want moles of copper, so that's going to go down here. We want nitric acid, and so that's going to go in the numerator. Where do these numbers come from, their ratio? From our coefficients in the balanced equation. So an 8 goes with nitric acid, and a 3 goes with copper. And so when we go ahead and we do that, we come up with 0.055 times 8 divided by 3 gives us 0.147 moles of nitric acid. Again, we can only change from one thing to another, so the copper to nitric acid with our mole-to-mole ratio. But this question wants us to go one step further to grams of nitric acid. Well, that's pretty easy now because we have moles of nitric acid. So 0.147 moles of nitric acid. And what are we going to do to get to grams? We're going to multiply by nitric acid's molar mass. And its molar mass is 63.02 grams in a mole. And we will get our answer to 2 significant figures, because that's what we started with in the beginning of the problem, of 9.3 grams of nitric acid. All right, let's go ahead and try another problem. Okay, we're using the same balanced equation. We're starting with the same mass of copper, but this time we're starting with grams of copper, and they're asking us how many grams of water can be formed. Well, first thing we have to do is get moles of copper. Then how do we get over here to water? Mole-to-mole ratio. Then we'll have moles of water, but we want grams, and then we'll use water's molar mass. So take it one step at a time. The first step, make sure you have a balanced equation, and we do. The next step is for us to convert whatever we've been given to moles. It was nice when we were given moles. So this is the first step that we did in the last problem. We're dividing grams by the molar mass of copper, and we get 0.055 moles of copper. But we don't want moles of copper. But that amount of copper, and we're assuming that we had plenty of nitric acid, like we just had an excess of nitric acid. So this copper is going to limit what amount of product we can make. And so we're going to put moles of water on the top, and we're going to put moles of copper on the bottom. Again, mole to mole ratio using the coefficients in our balanced equation, 4 to 3. And so how many moles of water will 0.005 moles of copper produce? Well, it'll produce 0.0734 moles of water. But that's not what we want. We don't want moles of water, we want grams of water. And so here we go. 0.0734 moles of water. We have moles and we want grams. In 1 mole of water, there is 18.02 grams. That's the molar mass of water. We've used it before, so that number should sound familiar. So 0.0734 times 18.02 is equal to 1.3 grams of water. What we just did is we used our balanced equation. We converted whatever we started with to moles. We used the mole to mole ratio to go to what we want, and then from moles of what we want, we went and answered the question, how many grams of water can be formed? So we converted those moles to grams. What I suggest you do when you're done watching this video is to go back and try these problems on your own without looking at the answers and see how you do. Well, let's try one more. Again, same balanced equation, starting with the same amount of copper. And so 3.5 grams of copper, when we divide by its molar mass, will give us the moles of copper. And it's 0.055 moles of copper. Okay, now they're asking us about nitrogen monoxide. We've got moles of copper, we need to go to moles of nitrogen monoxide. And nitrogen monoxide is a gas. So let's go ahead and do our ratio. Moles of nitrogen monoxide goes on top, because that's what we want. Moles of copper go on the bottom. Our balanced equation shows 2 to 3. So 0.055 times 2 divided by 3 gives us 0.037 moles of nitrogen monoxide. Now, if this question asked for grams, we would multiply by the molar mass. But it's asking how many liters of this gas at STP. Do you remember what we did when we had moles and we wanted liters of a gas at STP? We have moles, so we are going to multiply. And in 1 mole, there are 22.4 liters of a gas if we're at standard temperature and pressure. And so our answer turns out to be 0.82 liters of nitrogen monoxide. Okay, so what we are doing, and I think this visual, it really helps me. We start off with something. We might start off with the volume of a gas, or we might start off with particles or a mass. The very first step you have to do is get to moles. And then we can go from moles of one thing to moles of something else using the mole to mole ratio from our balanced equation. And now you're here in the center, and it's a completely new substance from our balanced equation. We got from one substance to another substance using mole to mole ratio. So that's why we had to get to moles first. Use the mole to mole ratio, and now answer the question. Did they ask for particles? Use Avogadro's number. Did they ask for the volume of a gas? Use 22.4. Or did they ask for grams? Then you would use the molar mass. Okay, so this video really didn't teach us anything new at all. It's just combined everything that we've learned and put together the mole to mole ratio with what we had already learned. We're going to practice this and we're going to do some pretty fun labs with this. Have a good evening.